Hello everybody, hope you're having a good day today, and today is going to be part 2 of the physics series, and today we're just going to go over the basic intro of one of the most important parts, which is vectors. These are going to be very important, and they're probably going to show up a lot. I'd say it's a safe assumption to say it's one of the most important things that you should be clear on. And then we're going to talk about different quantities and such as for example, I'll say position, displacement, all that kind of stuff. So we'll talk about different quantities here. And then we're going to go over the units of these quantities. So there's going to be meters per second. So everything's going to be in metrics mostly in most of your physics classes. And so we're going to go over the units for each of the quantities. And then we'll talk about a bit of the small details kind of stuff like direction and how to set up what in a straight line, all that kind of stuff. But we won't go over any of the formulas today. I just want to give a brief introduction of vectors and make sure that everyone understands what vectors are, because these are going to be important in kinematics. So I hope you're excited, and let's get started. Alright, so let's get started. So let's first talk about what a vector is. So a vector is essentially a quantity, and let me draw a vector. So usually a vector has a tail and a head, and this would be the tail, this would be the head. And essentially this quantity has a magnitude, and write that a bit cleaner. So this quantity has a magnitude, and this magnitude basically sort of says how long it is, or it gives it a value that you can identify that vector. And vectors also have a direction. So I could say, for example, this vector right here, it is a magnitude vector of, let's say, 6, and I'll write that in a different color, and it has a direction, let's say, I'll put a degree here so it'll make more sense, I guess. And let's say it has a 30 degree. So we could say that this vector has a magnitude of 6, and its direction is towards the east, because if we think about a compass, for example, okay, so a compass, this being our north, east, and south, and west, this would be like a vector that is east, and it's put up 30 degrees to the north. So what essentially I'm saying here is that a vector can have a direction, and not can, but it does have a direction. That's what a vector is. So, and then we'd characterize this vector as vector A, for example. And this symbol tells us that it's a vector. And here we can also write out the units for the vector, but it's not really necessary in physics. But if you are curious, there are unit vectors, and these vectors are essentially like 1 unit long. And so if you think about this in an XY table, what this vector would be is there's a special letter that's used for this, and it's just I. And for this is J. And what this essentially means is that there is, let's say on a, let me draw that a bit better. So let's say on an XY coordinate system, right? What I would be essentially is just a point right here. In fact, let me draw that in different. Let me do that in a different color. So this would be I right here. So that would be I, and this is in a different color for J, and this would be like, for example, J, and they'd just be like 1, and then this would also be 1. So essentially, it's just a vector that is this, and then for J, it's just this vector. And these are just common vector units, but we don't need to really know that. And it's not too important, but it is. If you are interested, then you can use that if you wanted to. But most of them won't be. So this would be like and then each vector can be split into components. So what these components are vectors in specific directions. So we know that x direction, like xy coordinate system, would be like this, right? We know this is the x-axis and this is the y-axis. Now here for vectors, it's essentially the same thing. So if you're aware of triangles, you know that if you know about the Pythagorean theorem, there's the triangle has two bases, base and a leg, right? So this would be like side A, side B, and we know that the hypotenuse, which is this, would be a squared plus b squared over a root of that. So meaning if you use a Pythagorean theorem, then we know that you could get this side, and I'm just going to call that C for now. But the same thing with vectors. So since we know that if I were to draw a right triangle, right? So for example, I'm going to draw the same vector, and this is the right triangle, and this is a 30-degree angle, and this is 6. If we know that, then using common trigonometry, you're going to need trigonometry in physics. If you don't know trigonometry, try to learn some basic trigonometry. So that's going to be really useful. But if you do know what this side would be, let's say x and y would be 6, for x it would be 6 cosine 30, right? Because cosine is basically adjacent over hypotenuse, so x over 6, which if you were to multiply it out would be 6 cosine 30, and then y would be 6 sine 30. And same thing, since sine is opposite over hypotenuse, that would give you the same thing, and that would essentially be how you calculate the components of a vector. So if you're getting the magnitude, you can just take the cosine and the sine and get the components in xy direction. Now, I think that's really all you need to know about vectors. Let's get into the actual definitions of some physical quantities. Alright, so let's get started. So in the previous section we learned about vectors, right? So we learned that, let me write this again. So we learned that vectors, okay. Alright, so in the previous section we learned about vectors. So vectors are essentially a quantity that has a magnitude and a direction. And so I said that, for example, I gave that line that had a magnitude of 6 and a direction of 30 degrees. So that would be a vector. Now there's another quantity in physics or in math or general called scalars. And scalars are essentially quantities that only have magnitudes. So you could think of a scalar basically as just a normal quantity. You don't have a direction. So that's the main difference between a vector and a scalar. So whenever you hear someone say a scalar, you know that this is just a quantity with a magnitude and no direction. So it does not have direction. That's what separates a vector from a scalar. So why is this important necessarily? So it's important because physics has a few quantities that are sort of similar, but they're different only because one is a scalar and one is a vector. So this one isn't different, but this is just a basic definition of position. And it's basically where you are in the current moment of time. So it could be like, let's say I'm on a number line and this is like 0. And let's say a person is here at the point 3. Let me do a different color. So 3. That means we can say that this person is at position 3. So that is essentially what position is. It's a pretty basic definition. Now, here's where we talk about two things that are sort of similar, but they're separated because of scalars and vectors. So one is distance, and I'll talk about distance in a moment, and then the other one is displacement. So what is the difference really? So what distance is saying is that it's basically what you think it sounds like. So it's the distance you have traveled in a specific period of time, or just in like a journey, for example. So this is actually a scalar value because, you know, when we talk about, let's just say normal talk in English, when we say someone traveled 200 meters, we don't usually say, oh, this person traveled 200 meters north or something like that. We don't necessarily say that. We just say the total distance. So for example, let's say this is me and I'm on the 0 position. Let's say I'm a different color. Let's say, I don't know, blue. So let's say I'm blue, right? And I traveled to 4, right? And then I traveled to -4. And so that means my total distance that I covered was 8, right? 8 units. But in what displacement is saying is that, and displacement is a vector, so that means it does have a direction. So what, let me write that better. So what displacement is it's essentially how much distance, like how far away is a certain object or certain thing from the starting point. So in this exact same example, right, where I talked about I'm at position 0, oops, let me just label that and I'll talk about 4 and -4. So it's basically like, okay, so I said I'm at position 0, I went to 4, and then I went all the way back to -4. My displacement, however, would be -4 units. That's because I am -4 units from my starting position. That's very different from distance. Distance is just the total, like total meters that you cover, or total, like all the places you went to. The displacement is just from the starting point, how far am I, and that's -4. So that's two things that are sort of similar, but one is a vector and it's a scalar, and that gives a very different definition. And that's something that a lot of people get confused with, but don't be confused with that. Distance just means how much how far, like did I travel? Displacement just means how far am I from my starting position. Okay, now let's talk about another kind of example, another kind of quantity which is also similar, has a vector and a scalar, and this is also pretty commonly confused. So, and also I forgot to mention, so that -4, right? That -4 mentioned my direction. So, for example, this is going to be kind of like a kind of small thing, but let's just talk about it. So again, the number line. Let's say I said this is a positive direction and my negative direction because I had 0 set up and I had +4 to the right, -4 to the left. What I am essentially doing is that when I say -4 meters, right, I'm saying, okay, so I'm -4, so I'm somewhere here. So that's my direction. It could have also been said as, let's say I consider this right side to be right and this is left. I could have said I was here. I could have said I'm 4 meters to the left, and that just means 4 meters left, right? It's just simple, like, but just remember directions, important vectors. But if it was distance, I could have just said 8 meters, right? That's what I did. Okay, so next let's talk about speed versus velocity. So I'm sure you all have heard of speed, like someone's going like 10 miles per hour or 10 meters per second, something like that, right? And that's essentially that's just a magnitude, right? That's just, I'm not saying that, oh, okay, this person went 10 meters per second to the north. That, if I said that, then that would be that person's velocity. So what it is basically, it's your change in speed is your change in distance over time. So, well, how much distance you're covering a certain time, if you do the ratio, so like my distance traveled divided by my time that I traveled that distance, right? That would give me my speed, and I'm just going to note that as S, right? And then this is just a value, and let's talk about quantities here. So in physics, you'll most likely see the most common would be meters per second. There are moments where you see kilometers per second, but usually they want you to convert to meters per second, and this is like the standard unit. So SI, I'm just going to write that standard unit for speed. And so velocity is also the same thing here, but velocity here, I have to, since it's a vector, and let me just label this as a scalar so we remember. So speed's a scalar. Now since velocity is a vector, what essentially I automatically know is I need a direction. So what velocity essentially is your displacement, since your displacement's a vector, over the time, because a time does not have a direction, right? So this is a vector upon time, and that will give us v, which I'm going to notate as velocity. And so that means since this is a vector, you'll usually see units, well, it would be meters per second, right? But you might see like to the left. So he's going 10 meters per second to the left, or you might see 10 meters per second to the right, or something like that. So it will have a direction. All velocity must have direction because it is a vector. Now, let's talk about, I guess we can talk about like time essentially, right? So what is time? So time is actually a scalar. However, time is also like it's also sort of different from a scalar. Just know time for units and time is always going to be in seconds. If you're ever given like 3 minutes or 2 minutes here, you want to convert that to seconds. So make sure that time is always in seconds. So time is always seconds. And unless it's like specified that they want, okay, I want like this many minutes, how many minutes is that? But always remember, most of the time it's going to be in seconds, especially on the AP test, always seconds. So that's one unit. So we talked about the units of distance, which is meters. There are cases where they might have kilometers, but mostly they'll want you to convert to meters. So I'll just keep them between that. And there's sometimes centimeters, but you want to convert to meters as this is the standard unit for distance. Velocity standard unit is meters per second, and we talked about that. And sometimes kilometers per second, but you want to convert to meters per second. Now, the last quantity that I want to talk about is acceleration. So this one's a kind of an important one, and what acceleration is like the definition of acceleration is the rate in change of velocity. So how much like the velocity, like the change in velocity over a certain period is your acceleration. So it's how fast the velocity is changing. Like how velocity was how fast the distance is changing. This is how fast the velocity is changing in a certain period of time. And that how fast or the rate of change is a key word. And like in the upcoming videos, we're going to talk about graphs, and we're going to have like, I'll just give a sneak peek, I guess. So we'll have like we'll have like graph setup here will be like distance versus time. We'll have velocity versus time, and the definitions will be really key in understanding what these graphs mean, because these are actually a really common part of the multiple choice in a lot of AP physics tests. And if you don't know how to interpret the graph, then you're gonna have a lot of trouble. So definitions really do matter here. So acceleration is the rate of change of velocity. So acceleration has units in meters per second because it's the rate and change of velocity. And if you do dimensional analysis, we know velocity's standard units are meters per second. Time is in seconds, and this would give you essentially this, meters per second, right? So usually this is the standard unit. Sometimes you might see centimeters per second square or kilometers per second square. You always want to try to get to meters per second square, and on the AP test you're always going to do meters per second square. So that is the standard unit of acceleration. Now acceleration, there's a lot of stuff to it, and we'll talk about the formulas next week, and you can calculate this. And actually I kind of given you a formula right here, but I'll go in depth into that next video. So I think that's good enough for the first part. This is just an introduction. So again, just to recap, the importance between vectors versus scalars, and just knowing what quantities are scalars, what quantities are vectors. And then I went over position, distance, displacement, and velocity and acceleration. And those are sort of key. They're basically all the units that you're going to need in this kinematics portion. Now there's going to be one more that's going to be added, but it's not too difficult. It has to do with acceleration. There's going to be gravity, which have a specific value to it, like a constant value, but that isn't too important as of right now. So I hope you enjoyed this video. This is just an introduction to like AP Physics and Physics 1, just learning about vectors and all these quantities. If you liked the video, please smash that like button down below. Comment below if you want to see something in the series, or you want to add to like something that you think is missing or could be added on. Write that in the comment section below. Please subscribe to the channel if you haven't, and I hope to see you soon in the next video.